All right, so we're talking about the secant line. I've introduced this to you before. So secant line is just a line drawn between two different points. So let's start with this one right here first. So this is the point A, and this is the point A plus H. So the slope would be the change in the y values. So that's f of A plus H minus f of A, divided by, and the denominator would be A plus H minus A. Oh, that's just H, and that's what that is. So slope of the secant line is the same thing as saying average velocity, because that's change in distance over change in time, right? Okay, so that's between these 2 points, A and A plus H. So I couldn't find one with just a nice glorified picture with this. So let me just change this to B and f of B. And this would be the x value of B. All right. So if I want to find the change in the y values, I would take f of B and subtract off f of A and divide by the difference B minus A. So these two mean the same thing, right? They're just using different notation. And I want you to be familiar with both. So this is saying if I've got this point P and I start off with Q1, I could find the slope of a secant line. But then if I moved that point Q1 to here, I would get that secant line. Do it again, Q2. So then what I'm doing is I'm moving the point Q in closer and closer. Okay, so there's Q4. So what happens if I put Q, let's just say, 100, right there beside P? And so what that turns out to be is a tangent line. So the secant line gets closer and closer and closer, so it finally gets to a tangent line. It's probably not 100, it's probably like 100,000. So this is the tangent line, and you know that process of getting closer and closer and closer, that's a limit. Okay, so here we go. So this is what the picture looks like as I'm getting closer and closer. So tangent line means this. And so now I'm just moving that point into here. And so this is the formula to find the slope of the tangent line at one point A, because it's going to change depending on what point A we pick. This is going to be the formula we'll work on in section 10 that gives us the slope of the tangent line at any point x. Well, let's stop with that and just go to the A. All right, so these are the two that will be on your memory quiz on Thursday. So you have to write this when I say find the derivative or the slope of the tangent line at the point A. You have to write all of that. And I say without h. This is with h. And the same thing for velocity. It gives you the same thing, only it uses the letter s for the function. Okay, all these things mean the same thing. Slope of the tangent line, the derivative, instantaneous velocity, instantaneous rate of change, all mean the same thing. Okay, let's play with the definitions. So here, this is like a Jeopardy game. Here's the answer. So what function am I using? And what's the point A that I'm using? So first off, I would look to see, am I using with h or without h? Well, I'm using with h, right? Okay, so if I'm using with h, that means I'm looking at this formula. Okay, so that means this has to be f of a plus h. This has to be f of a. And then h is in the denominator. So I want f of a plus h to equal 3 plus h squared. And I want f of a to equal 9. Okay. What does a have to be and what does f of x have to be? Think about it. I'm thinking the function has to be x squared. And then the a would have to be 3. So f of a plus h, put it in the function. F of a, put it in the function x squared, right? That works. Okay, let's try another one. Let's look at this one. Is this with h or without h? So this is without h, right? Okay, so without h. So let me come up here, get rid of some of these lines. Okay, so if I'm going without h, I'm looking at this. So without h, what I'm looking for, and I'm looking for what the f of x is and what the a is, right? So if I'm without h, that means that I have to have f of x minus f of a over x minus a. Hey, I think we can find it. I think a is spelled out to us, isn't it? It's 2. And so what must the function be so that f of a gives me 8 and f of x gives me, oh, it's just x cubed. You see it, right? Okay, let's try, oh, I better stop here and start again.